What does it mean for something as vast as the universe to end? Not simply to change or cool or grow quiet for a while, but to arrive at a final condition beyond which no story can continue. For centuries, human beings have lifted their eyes to the night sky and seen permanence there. The stars seemed fixed. The darkness between them felt eternal. Heaven, in one form or another, appeared stable. Then science began to unsettle that comfort. In the early 20th century, physicists and astronomers discovered that the cosmos is not a still painting hung above us. It is dynamic. It stretches, shifts, evolves. Galaxies drift apart like sparks from a fire no one witnessed directly, and time itself carries the marks of a beginning. Once that truth entered human thought, another question followed with quiet force. If the universe had a beginning, does it also have an end? The answers are not simple. Some are mathematical, some are physical. Some exist at the edge where knowledge turns into philosophical unease. A few suggest collapse. Others imagine endless thinning, a long exhaustion of light and warmth. Some propose that reality could unravel without warning, not through malice or design, but because the laws beneath existence may be less permanent than they appear. And yet these theories are not only about destruction. They are mirrors. In trying to imagine the death of the cosmos, we reveal something about ourselves. Our fear of disappearance, our hunger for meaning, our need to believe that memory matters in a universe measured in billions of years. So this is not only a story about endings, it is a journey through the strange and beautiful ways human beings have tried to understand impermanence at the largest scale imaginable. Because when we ask how the universe will end, we are also asking a more intimate question. What, in the end, does it mean for anything to last? What if the universe does not fade away, but turns back on itself? In 1922, when Russian physicist Alexander Friedmann worked through Einstein's equations, he found something deeply unsettling hidden inside the mathematics. The universe did not want to sit still. It could expand, it could contract, and if enough matter filled the cosmic vastness, gravity might one day overcome expansion and summon everything home. This idea became known as the Big Crunch, though the name almost sounds too small for what it describes. Imagine the long, outward motion of galaxies slowly losing momentum. Over unimaginable ages, the distances between great clusters would stop increasing. The expansion would hesitate, like a breath held too long, and then reverse. The universe would begin to fall inward. At first, the change would be subtle. The night sky might grow brighter as remote galaxies edged closer. But over billions of years, subtlety would give way to pressure, heat, and crowding. Stars would gather into denser swarms. Galaxies would collide not as rare spectacles, but as a new cosmic normal. Space itself would tighten. Radiation would intensify. Darkness, the background condition of the universe we know, would slowly be erased by an all-encompassing glow. In that closing era, matter would be driven towards states no civilization could truly witness and understand. Temperatures would rise toward extremes last seen near the beginning of time. Structure would fail. Atoms, then nuclei, then the familiar boundaries of matter might lose meaning altogether. Everything built across billions of years, every planet, archive, ocean, language, and living face would be drawn into one final compression. And here the theory becomes strangely poetic. The universe may not end in chaos, but in symmetry. The same cosmic story that began in a singular state could conclude by returning there as if time had folded back toward its first page. But if everything can be gathered again into a single point, was the beginning a birth, or merely the memory of an earlier end? What if the end arrives not with violence, but with absence? In the 19th century, as steam engines and industry transformed daily life, physicists were uncovering a quieter law beneath all activity. Energy, they realized, always spreads out. Heat moves from warm things to cool ones. Order dissolves into disorder. The universe, taken as a whole, seems to drift in one direction only, toward equilibrium. From that insight came one of the most haunting visions in cosmology, often called the Big Freeze. It does not imagine a sudden catastrophe. It imagines a universe that simply uses up its differences. The bright places dim. The active places grow still. The great machinery of stars, galaxies, and living worlds continues for a very long time, but not forever. At first, almost nothing would seem unusual on a human scale. Galaxies would still turn in darkness. Suns would still burn. But over trillions of years, the fuel that powers the stars would thin out. The smallest, longest-lived stars would endure the longest, glowing patiently in the dark after brighter ones had died. Eventually, even they would go out. What remains would be a cosmos of remnants. White dwarfs cooling in silence, neutron stars fading into invisibility, black holes lingering like the last deep notes of a song. The unsettling part is the pace. No single generation would witness the end. Instead, each age would inherit a universe slightly colder, slightly emptier, slightly less generous with light. The sky would not collapse. It would withdraw. In the farthest future, even black holes may evaporate, leaving only sparse particles and weak radiation spread across distances so large they almost defeat imagination. Space would remain, time would continue, but nothing meaningful would happen. No fire, no growth, no new complexity rising out of darkness. It is an ending defined not by impact, but by exhaustion. And perhaps that is why it feels so intimate. We know in our own smaller ways what it means for warmth to leave a room, for a voice to fade, for something once full of life to become still. If the universe ends in cold equilibrium, then its final lesson may be the oldest human one of all. That loss is not always loud. But what if an ending is never truly an ending? Some physicists have imagined a universe that does not move in a straight line from birth to death, but in cycles, vast expansions followed by collapse, each one giving rise to another. In this view, the Big Bang may not have been the first moment of everything. It may have been a rebound, the latest awakening after a previous cosmos fell inward and reached a limit beyond which compression became renewal. This idea, often called the Big Bounce, carries a strange emotional force. It softens the finality of extinction while deepening another kind of unease. If the universe can begin again, then perhaps reality is less like a novel and more like breathing. Expansion, contraction, release, return. Time would not be a road with a destination, but a rhythm older than memory. There is something almost comforting in that image, a cosmos that refuses absolute ending. A universe capable of beginning again after its own ruin. Yet the comfort does not last long, because in most versions of this theory, nothing survives the transition in any meaningful way. No memory crosses the threshold. No civilization leaves a message for the next cycle. Every work of art, every language, every grief and triumph would be reduced to raw possibility, folded into conditions from which a different universe might emerge. The next cosmos could resemble ours, or it could be utterly unlike it. Its laws might shift. Its stars might form differently. Life, as we understand it, might never appear there at all. Our existence would not be continued. It would be erased and replaced. And still, the mind lingers on a quieter mystery. If reality has passed through such cycles before, then this may not be the first universe to wonder about its own beginning. There may have been countless skies before this one, countless worlds filled with beings who also looked upward and asked where everything came from, just before their answers vanished with them. The Big Bounce offers no immortality. It offers recurrence without remembrance, and that may be even more unsettling than a single final end. Because if the universe begins again and again, but never carries its wisdom forward, then what exactly does eternity learn? What if the force pulling the universe apart never weakens, but grows stronger with time? At the end of the 20th century, astronomers made a discovery that changed cosmology forever. The universe was not merely expanding, it was accelerating. Something woven into the fabric of space itself seemed to be pushing galaxies away from one another with increasing urgency. That invisible influence came to be called dark energy, a name that explains almost nothing and yet names one of the most important realities in modern physics. Most of the time, dark energy sounds abstract, almost harmless. It reveals itself only across immense distances in the slow drifting of galaxies. But some theorists asked a more unsettling question. What if this expansion does not remain gentle? What if the pressure driving space outward becomes stronger as the universe grows? What if the future is not cooling, but tearing. This is the vision known as the Big Rip. In that scenario, the process begins far from us, in the architecture of the cosmos itself. Galaxy clusters would first lose their grip on one another. Then individual galaxies would come apart, their stars no longer bound in graceful spirals, but scattered into the widening dark. Later, solar systems would fail. Planets would no longer circle their stars. Orbits would unravel. The night sky would not simply go black, it would lose its structure, and then the violence would move inward. If the expansion became extreme enough, it would no longer stop at stars and worlds. It could overcome the forces that hold matter together. Mountains, oceans, cells, molecules, everything assembled over cosmic history would be separated piece by piece. In the final instant, even atoms might not survive. Space would not merely contain destruction. Space itself would become the mechanism of it. What makes this theory so haunting is its intimacy. Many cosmic endings feel remote, unfolding over spans too large to emotionally grasp. The Big Rip is different. It imagines the universe turning against the very idea of togetherness. Not just worlds ending, but bonds ending. Not just light fading, but connection itself being undone. And that leaves us with a question both scientific and human. If reality is held together by invisible forces, how much of existence depends on tensions we barely understand until they begin to fail? What if the universe does not die slowly, or even dramatically, but vanishes because the rules beneath reality suddenly change? Modern physics suggests that the world we know is built on fields, deep, invisible structures spread throughout space, shaping everything from mass to light to the chemistry of living cells. Most of the time, we treat those fields as stable, the silent background of existence. But there is a troubling possibility hidden inside quantum theory. Stability may be temporary. What appears settled may only be resting in a fragile state, like a stone balanced on a ridge above a darker valley. This is the idea behind vacuum decay. The phrase sounds technical, almost sterile, yet the concept is among the strangest in cosmology. It proposes that our universe may not occupy the lowest possible energy state. Instead, reality could be living inside a kind of false floor, durable for now, but not ultimate. If somewhere in space a tiny region were to fall into a deeper state, it would create a bubble of altered reality that expands outward at the speed of light. Inside that bubble, the laws of physics would no longer be the ones that made stars, oceans, or human bodies possible. The constants governing matter could shift. Atoms might no longer hold together. Chemistry could fail instantly. The delicate arrangements that permit memory, sensation, and life would not be shattered in the familiar sense. They would simply cease to be viable under the new conditions. A person would not witness the change approaching because nothing can outrun light. There would be no warning in the sky, no final sound, no time to understand. That is what gives this theory its peculiar emotional weight. It is not a story of collapse after ages of decline. It is a story of ordinary existence interrupted without ceremony. A cup on a table, a city at dusk, a child asleep. And then the structure beneath all those scenes replaced by something that cannot hold them. Vacuum decay reminds us that permanence may sometimes be only an agreement between forces, not a guarantee. And if the universe can appear solid while resting on hidden instability, how often in human life do we mistake endurance for certainty? What if the universe reaches its end, and then, out of perfect emptiness, something stirs again by accident? The laws of thermodynamics describe a cosmos moving toward equilibrium, a final condition in which energy is spread so evenly that no useful work can be done. It is the logic behind heat death, the long cooling of everything. But quantum physics adds a strange afterthought to that quiet future. Even in near-perfect stillness, tiny fluctuations may continue. On the smallest scales, absolute calm is difficult to imagine. Reality shivers. This possibility creates one of the most unsettling ideas in modern cosmology. A dead universe may not remain entirely uneventful. Given enough time, far more than language was built to handle, random fluctuations could briefly assemble small pockets of order out of surrounding disorder. Not stable worlds, not lasting histories, just temporary structures, formed by chance and then gone again. At first, this sounds almost hopeful, as though the universe might generate new beginnings from its own silence. But the deeper implication is darker. In a cosmos where fluctuations occur across unimaginable stretches of time, it may be easier for a single isolated consciousness to emerge than for an entire rich universe to form around it. A mind could appear for an instant, carrying the illusion of memory, identity, and context, only to disappear back into nothing before any of those memories had a chance to connect to a real past. It is a vision of recurrence without meaning, not rebirth but interruption, not a second creation, but a statistical accident. What makes this theory so haunting is the way it blurs the boundary between existence and narrative. We assume that memory points backward to something that happened. We trust continuity. We believe our inner lives belong to a real chain of events extending through childhood, history, and the formation of stars. But in a universe ruled by enough time, chance can imitate biography. The question here is not only how the cosmos ends, it is whether meaning depends on duration. If a consciousness can briefly exist with convincing memories in a silent universe, is experience alone enough to make something real? Or does reality require a story that truly happened? What if time itself is not endless, but a temporary feature of the universe? We usually imagine cosmic endings as physical events, a collapse, a freezing, a tearing apart. But some ideas in theoretical physics point somewhere even stranger. They suggest that the deepest limit may not involve matter or energy at all. The limit may belong to time. In certain models of an eternally inflating cosmos, physicists have encountered a disturbing problem. If the universe produces events forever, then probabilities become difficult, perhaps impossible to define. In an infinite expanse with infinite outcomes, comparison begins to lose meaning. To make the mathematics work, some researchers have explored the possibility that time, as a meaningful framework for events, may require a boundary. Not a wall in space, but a terminus in duration itself. This idea is difficult to picture because thought depends on sequence. One thing happens, then another. Memory gathers what is gone. Expectation leans toward what comes next. Remove that structure, and the language of experience begins to fail. A universe without future moments is not simply frozen like an image. It is something more radical. The very distinction between before and after dissolves. What makes this possibility so unnerving is the absence of drama. There may be no fire in the sky, no visible fracture in the stars, no cosmic sound announcing a final hour. The galaxies could continue in their majestic silence. Atoms could remain arranged exactly as they were. And yet if time itself reaches a limit, then no process can continue. Thought cannot proceed. Motion cannot unfold. Cause can no longer reach effect. It is an ending without spectacle, a conclusion so absolute that even the idea of afterward becomes meaningless. Perhaps that is why it touches something deeply human. We measure our lives in time, but we rarely ask what time is, beyond the medium in which loss and hope take shape. If time is not eternal, then every memory and every promise exists inside a finite vessel more fragile than we imagine. And if the future itself can run out, what becomes of meaning when there is no next moment left in which to carry it? What if the instability is not hidden in some unknown realm of physics, but inside the very field that gives matter its weight? In 2012, the discovery of the Higgs boson was celebrated as a triumph, the confirmation of a missing piece in the standard model of particle physics. It helped explain why fundamental particles possess mass, and for a moment it seemed as though humanity had illuminated one more dark chamber of reality. But scientific discoveries have a way of opening new uncertainties just as they resolve old ones. The measurements that followed hinted at something unsettling. The Higgs field may not be perfectly stable. That possibility gave rise to a scenario sometimes described with uneasy humor as the Big Slurp. The Higgs field fills all of space. It is not an object in the universe. It is part of the condition that makes the universe recognizable. If that field were to shift into a lower energy state, even by a quantum transition no human being could foresee, the consequences would reach into every atom. The masses of elementary particles could change. Electrons might behave differently. Quarks might settle into new relationships. Chemistry, as we know it, would no longer work in the same way. The table of elements would become a relic of a previous cosmos. Unlike more speculative endings, this one feels disturbingly precise. It emerges not from mythic imagery, but from numbers measured in laboratories and tested against equations of extraordinary success. The terror here is not theatrical, it is clinical. Reality may be exquisitely ordered, yet balanced in a state that is not final. If such a transition began somewhere in the universe, it would spread as a new condition of space, rewriting the foundations of matter wherever it passed. Stars would not explode in protest. Living things would not have time to comprehend what had happened. The world would simply become incompatible with itself. There is something profoundly humbling in this idea. We like to think knowledge secures us, that understanding the cosmos brings a little more ground beneath our feet. But sometimes understanding reveals the opposite. It shows us that the floor itself may be provisional. And if the fabric of existence depends on values so delicate that a slight change could erase everything familiar, then perhaps the true wonder is not that the universe may be fragile, but that it has held together long enough for us to notice. What if the universe does not end through fire or silence, but through abundance so vast that meaning itself begins to dissolve? In the early 1980s, cosmologists developed the theory of inflation to explain why the universe appears so smooth, so flat, and so strangely uniform across enormous distances. It proposed that in its first tiny fraction of a second, the cosmos expanded with breathtaking speed. Later, some physicists followed that logic further and arrived at an even stranger possibility. Inflation, they argued, may not have ended everywhere. It may still be happening beyond the horizon of what we can see, endlessly generating new regions of reality. This is the idea known as eternal inflation. In such a picture, our universe is not the whole story. It is one bubble among countless others, each born from the same inflating background, each potentially governed by slightly different conditions. New universes would continue forming without end. Some might resemble ours closely enough to contain stars, galaxies, and thinking beings. Others might be so different that matter never gathers, or time itself behaves in unfamiliar ways. At first glance, the theory feels expansive, almost liberating. It suggests creation is not a singular event, but an ongoing process, a cosmic flowering beyond any horizon we can reach. Yet buried inside that grandeur is a quieter discomfort. In an infinite multiverse, what becomes of uniqueness? If every physically possible arrangement occurs somewhere, then every path branches into countless alternatives. Every human life becomes one variation among uncountable versions. Every joy, every mistake, every civilization, every extinction is echoed elsewhere in forms similar or wildly different. The rarity that gives events their weight begins to thin. This is not destruction in the ordinary sense. It is dilution. A universe once imagined as singular and precious becomes one instance in a reality too prolific to hold easily in the mind. The question is no longer whether something happened, but how many times it happened, and in how many ways. And so eternal inflation confronts us with a subtle ache. Perhaps the end of meaning does not require darkness at all. Perhaps it begins when existence becomes so endless, so repeated, that the human longing for one irreplaceable story can no longer find its footing. What if the deepest threat to reality is not that the universe will disappear, but that consciousness itself may become a statistical error? In some models of the far future, a universe dominated by expansion does not simply grow emptier. Over incomprehensible stretches of time, it becomes a place where rare fluctuations can still occur in the thin background noise of existence. Most would be trivial, a particle here, a brief pattern there. But given enough time, even the absurd becomes possible. A structure as intricate as a thinking mind could momentarily assemble itself out of chance alone. This is the unsettling logic behind the idea of the Boltzmann brain. The concept sounds almost like philosophy disguised as physics, yet it emerges from a serious question about probability. If the universe lasts long enough, random fluctuations may create isolated observers far more often than they create entire galaxies, planets, and evolutionary histories. A single mind with vivid memories is statistically simpler than a whole cosmos that genuinely produced those memories through billions of years of stars, oceans, biology, and time. That is where the theory becomes more than strange. It becomes personal. Because if such fleeting minds would eventually outnumber ordinary observers, then a troubling question appears. Why should we assume we are not one of them? Why trust memory, continuity, or the reality of the world around us? If chance could imitate them for an instant, a consciousness could arise in darkness believing in childhood, history, love, and loss, only to vanish almost immediately, its remembered life never having happened at all. The horror here is not physical annihilation. It is epistemological loneliness. The possibility that reality remains vast and lawful, yet experience itself can no longer be taken as evidence of anything beyond the moment of awareness. And still, there is a human response to this abyss. We go on trusting the continuity of the world not because certainty has been granted to us, but because living requires a kind of faithful attention. Perhaps the mystery is not that doubt exists, but that meaning persists despite it. If the universe can produce minds that mistake illusion for history, what finally makes a life real? The world behind it, or the depth with which it is felt? What if the universe does not merely approach an ending, but enters a region where our most trusted ideas, cause, duration, identity, begin to lose their shape? As cosmology has grown more sophisticated, one truth has become harder to ignore. The universe is not only stranger than earlier generations imagined, it may be stranger than ordinary language can bear. Every theory of the end eventually reaches a threshold where equations continue, but intuition fails. We can describe the motion of galaxies, the decay of fields, the thinning of heat, the branching of worlds. Yet somewhere beyond those descriptions lies a quieter frontier, the place where the fate of the cosmos becomes inseparable from the limits of human understanding. This chapter of the story is not about one single mechanism. It is about the convergence of them. Collapse, freezing, rupture, fluctuation, repetition, instability, each theory is also a portrait of uncertainty. Each one reveals that the universe may end in ways that are not just physically difficult to imagine, but conceptually difficult to hold. A final singularity compresses all distinction. A dead cosmos bursts accidental minds. Infinite worlds erode uniqueness. A changed vacuum erases the grammar of matter. Time itself may fail to carry events any further. Seen together, these are not only scientific hypotheses, they are meditations on fragility. And that fragility is not limited to stars or equations. It reaches into the human frame. We are creatures who build meaning from sequence, memory, and relation. We understand existence through continuity. This happened, then this, and therefore I am who I am. But many endings proposed by modern physics threaten continuity itself. They suggest that the universe may not preserve the forms of meaning we depend on. Perhaps that is why the question of cosmic endings remains so emotionally powerful. It is not only about what happens to the galaxies. It is about whether reality, at its largest scale, ultimately honors the structures by which consciousness makes sense of anything. And if it does not, then the mystery is no longer how the universe ends. The deeper mystery is how beings as temporary as we are ever learn to ask the question at all. What do all these endings have in common beyond their mathematics and their scale? Each one begins as a scientific model, but none remains merely technical for long. The moment we picture it clearly, a sky growing brighter as everything falls inward, a last star cooling into dark, a silent bubble rewriting physics, a future crowded with false minds, we recognize something familiar inside it. These are cosmological theories, yes, but they are also human metaphors for impermanence. We have always lived with endings. Civilizations rise and vanish, languages fade, cities become ruins, families carry stories for a few generations, then lose the names. Even the most intimate parts of life teach the same lesson in miniature. Warmth leaves, memory shifts, voices disappear from rooms where they once defined the air. The universe, in this sense, is not foreign to us. Its fate only magnifies the pattern we already know. And yet there is a crucial difference between human loss and cosmic loss. Human beings do not merely endure endings. We interpret them. We gather fragments into meaning. We turn grief into ritual, time into history, uncertainty into questions. That impulse may be one of the rarest things the universe has produced. Out of matter forged in stars came creatures capable of wondering whether the stars themselves will last. Out of blind physical law came tenderness, curiosity, and the strange dignity of trying to understand. That may be why these theories move us so deeply. They do not only threaten our future, they test our scale of values. If the cosmos ends in silence, does beauty matter less because it was brief? If reality is unstable, does love become trivial because it depended on temporary laws? If existence repeats without memory, is this moment diminished or made more precious by the fact that we can feel it now? The science does not answer those questions. It only sharpens them. And perhaps that is the hidden gift inside every theory of the end. It reminds us that meaning was never guaranteed by permanence. It had to be made here, within the fragile interval in which light, memory, and awareness briefly meet. So where does this leave us? After traveling through collapsing cold, through unstable fields, endless inflation, dissolving time, and minds that may flicker out of darkness by chance. It leaves us where all serious reflection eventually arrives, not at certainty, but at perspective. The universe may end in fire or silence, or transformation so complete that our current language cannot contain it. It may fold inward, it may thin into stillness. It may be rewritten by laws deeper than the ones that cradle our lives today. Or perhaps the true ending is not a single event at all, but the gradual realization that reality is larger, stranger, and less obligated to human intuitions than we once believed. Yet this is not a counsel of despair. Because the more fragile the cosmos appears, the more extraordinary it seems that anything tender or conscious has happened within it. For a brief span between the first light and whatever comes after the final one, the universe has produced beings who can remember, imagine, mourn, and ask questions larger than themselves. We are temporary, yes, but temporary things are not meaningless. A song does not need to last forever to be beautiful. A life does not need cosmic permanence to be real. Perhaps that is the deepest lesson hidden inside every theory of the end. The value of existence does not come from its guarantee. It comes from its rarity, its texture, its unrepeatable immediacy. We matter not because the universe was built to preserve us, but because against enormous odds, it allowed us to awaken within it at all. One day the stars may go out, space may fall silent, time as we know it may lose its path, but here in this fleeting era of warmth and memory, there is still music, still wonder, still the human instinct to reach for understanding. And maybe that is enough. Maybe the final mystery is not how the universe ends, but why a cosmos destined for impermanence gave rise to creatures who could look into the dark and answer it with curiosity, love, and light.